Exercise 4.6 from Calculus SM Yusuf book, question number 14. We need to evaluate this integral 1 over a plus b cos hyperbolic of x. Let this integral equals to I. I is equals to integration of 1 over a plus b cos hyperbolic of x dx. Now we need to use some identities here. We know that cos hyperbolic square of x minus sine hyperbolic square of x is equals to 1. So we can also write it like cos hyperbolic square of x by 2 minus sine hyperbolic square of x by 2 is equals to 1. So I am using this identity here with this a. We know that a can be written as a into 1. So I will use this identity here. Now we know that cos hyperbolic of x can be written as this. I am now solving this one. Cos hyperbolic of x can be written as cos hyperbolic 2 times x over 2. And we know that cos hyperbolic 2x, that will be equals to cos hyperbolic square x by 2 plus sine hyperbolic square x by 2. So I will replace this term with this identity. So our integral I will become equals to, I is equals to integration 1 over a times this identity. This is a times cos hyperbolic square x by 2 minus sine hyperbolic square x by 2 plus b times cos hyperbolic 2 into x by 2. This is here this term. So this will be equals to this identity. Cos hyperbolic square x by 2 plus sine hyperbolic square x by 2, and here we have dx. Now after opening these terms, we'll get I is equals to integration 1 over. This will become a cos hyperbolic square x by 2 minus a sine hyperbolic square x by 2 plus b cos hyperbolic square x by 2 plus b sine hyperbolic square x by 2 and dx. I am combining the sine terms and the cosine terms. So it will become I is equals to integration 1 over. Now I am taking cos hyperbolic square x by 2 common from here. Inside I will get a plus b. So it will be a plus b times cos hyperbolic square x by 2 plus here I will get b minus a sine hyperbolic square x by 2 and here dx. Now divide the numerator and denominator with cos hyperbolic square x by 2. Now I am dividing my numerator with cos hyperbolic square x by 2 and with my denominator cos hyperbolic square x by 2 like this. So it will be reduced as, my integral will be reduced into secant hyperbolic square of x by 2 over a plus b, this will be cancelled, plus b minus a tangent hyperbolic square x by 2. So my integral will be reduced as I is equals to integration secant hyperbolic square x by 2 divided by a plus b minus a tangent hyperbolic square x by 2 dx. Now I need some substitution here to simplify it. For that purpose, let tangent hyperbolic x by 2 is equals to z. So take the derivative on both sides, we'll get secant hyperbolic square x by 2 times 1 by 2 dx is equals to dz. Now we have only secant hyperbolic square of x by 2 and dx. So retain these terms here and move this 2 on the other side. We'll get secant hyperbolic square x by 2 dx will be equals to 2 dz. Use this substitution here in this integral. We will get here I is equals to, I will be equals to here integration 2 dz divided by a plus b minus a times z square. Now we assume that a plus b is positive. Assume that a plus b is positive. I am assuming that. Case 1. Here Case 1 will be if a square is greater than b square, then a square minus b square will be greater than 0. Then this means that you know that a square minus b square can be written as a minus b into a plus b. That will be greater than 0. So we can write like as a plus b is greater than 0, as we assume that this is positive. As a plus b is greater than 0, so a minus b is also greater than 0. So from this equation, this integral, let's mark this equation as equation number 1. From this equation number 1, we will get here I is equals to integration 2 dz divided by, I can write it like a plus b minus a minus b. I have taken minus sign common, z square. Now this can be written as I is equals to, take this 2 outside, and I am also taking this a plus b common as well. 2 over a plus b, and inside in integration we will be left with dz over, here we can write I am taking a minus b common, not a plus b. I am taking this term common. So it will be a plus b over a minus b minus z square will be left here. Now, why we did this case? Since this is positive, this is also positive, so we can write it in under root form. That's why we just let it that both are positive. If both are positive, then we can let it in under root whole square. So our integral, that is I is equals to 2 over a minus b integral dz over a plus b over a minus b minus z square. Now I can write it like I is equals to 2 over a minus b integral dz over, now this thing can be written as under root a plus b over a minus b whole square minus z whole square. Now this is the same thing I told you earlier, the integration of dx over x square minus a square minus x square. This will be equals to 1 over 2a ln of a plus x over a minus x. So using this formula here, my integration will be reduced into I is equals to 2 over a minus b into 1 over a, here is this term, this under root without square. This will be equals to 1 over 2 times under root a plus b over a minus b ln of this term a plus x. This is a and this is x. So it will be ln a plus b over a minus b plus z divided by under root a plus b over a minus b minus z. Now we need to simplify these terms. We know that this is in denominator, this is a square root, and this term can be written in like a minus b. This term can be written as a minus b into under root a minus b. So 1 over under root will cancel with this one. And here split this under root into like this, a plus b under root over a minus b under root. Take the LCM with this one, and then you will get two fractions in this main fraction. Cancel their denominators, and after simplification we will get here I is equals to 1 over under root a square minus b square ln a plus b plus under root a minus bz over under root a plus b minus a minus bz. Now what was our substitution in the start? Our substitution was z is equals to tangent hyperbolic x by 2. So replace this z with tangent hyperbolic x by 2. So I will be equals to 1 over under root a square minus b square ln of a plus b plus under root a minus b tangent hyperbolic x by 2 divided by under root a plus b minus under root a minus b tangent hyperbolic x by 2. Now we need to move on our second case. In the first case a square was greater than b square, and in second case a square will be less than b square. Let case number 2 now. In case number 2, if a square is less than b square, then a square minus b square will be less than 0. It means a minus b into a plus b is less than 0. This means that We have let in the start that a plus b is greater than 0. Assume that a plus b is positive. We have let it in the start. And the product is negative. This means this is positive. So it means this will be the negative one. So a plus b is greater than 0 and a minus b is less than 0. Means a plus b is positive, that we let in the start, and a minus b is negative. So now what was our integral? Our integral was I is equals to integration 2 dz divided by a plus b minus a z square. This was our integral. Now I am taking this b minus a as common because our a minus b is negative. Our a minus b is negative, so b minus a will be positive. If you multiply the negative sign on both sides, it will become b minus a. Sign will alter, this will become positive. So there is no need to change this sign and take this b minus a common and this 2 also common. I will get I is equals to 2 over b minus a integration 1 over a plus b over b minus a plus z square dz. Now this can be written as I is equals to 2 over b minus a integral 1 over. Now a plus b can also be written as b plus a and this term b minus a. Now write it in under root and whole square and this square dz. Now we know that we can just integrate it. How we can integrate it? We know that its formula, that is 1 over a tangent inverse x over a. You know the formula for that integral. Integration 1 over a square plus x square, that is 1 over a tangent inverse x over a. So using that formula here, we will get I is equals to 2 over b minus a times 1 over this a term. This whole term is a constant term, that is this one. This is 1 over under root b plus a over b minus a. Arc tangent means tangent inverse z over under root b plus a over b minus a. Now after simplification and substituting the value of z back, I will get I is equals to 2 over b square minus a square arc tangent under root b minus a over b plus a tangent hyperbolic x by 2. So plus constant of integration. So this is the answer for our question number 14. Now come on question number 15, that is cot of x divided by 1 plus sine of x. Let this integral I is equals to cot of x over 1 plus sine of x dx. This thing will become equals to, you know that cot of x is equals to cos of x over sine of x. So it will become equals to cos of x over, this sine of x will come down, sine of x times 1 plus sine of x dx. Now we will use some substitution here. Let sine of x is equals to z, so that we will get cos of x dx will be equals to dz. So on substitution, I will get here I is equals to cos of x dx will be dz divided by z into 1 plus z. And you know that how you can just solve this? You can solve this by using the partial fraction method. You will consider this function 1 over z into 1 plus z, partial fraction of it. Find the values of a and b. After finding the values of a and b, this a value will be 1 and b value you will get minus 1. Put back here and then integrate it. So after using the partial fraction here, we will get 1 over z minus 1 over 1 plus z dz like this. Now separate your integral. This will be 1 over z dz minus integral 1 over 1 plus z dz. So integrate it now. This will be equals to ln z minus ln 1 plus z. Now substitute back the values of z here. We will get here ln sine of x minus ln 1 plus sine of x. You can leave your answer here as well, but you can also simplify it further. You know that this is a property of ln. We can combine both ln as 1 and it will be sine of x, and the negative thing will come in the denominator like this. Now you can further simplify it. I is equals to, you can just leave it here as well, but further simplification is good. Ln sine of x over 1 plus sine of x. You know that you can write it like x can be written as 2 into x by 2. So it will be sine of 2 into x by 2, that is equals to 2 sine of x by 2 and cos of x by 2. So this will become ln 2 sine of x by 2 cos of x by 2 divided by, this term will become equals to 1 plus sine of x by 2 plus cos of x by 2. So after simplification and dividing it with sine of x by 2, divide the whole thing with sine of x by 2, and after simplification we will get here ln 2 tangent x by 2 minus 2 ln 1 plus tangent x by 2. But it's good if you just leave it here with this answer. Now move on to question number 16.